Okay, we are now on dimensional analysis. Now, my approach to dimensional analysis is a little bit different than the books, but he likes to use um, length, capital letters for the lengths. I just like using the parameters like meter squared or kilometer squared, or something like that. But we'll go through it just for completeness. So the dimensions and units of four derived quantities. Now, derived quantities means they're not fundamental. Just as we talked about volume, volume is length cubed, area is length squared, speed is length over time, acceleration is length over time squared. So in SI units, area is meters squared, volume is cubic meters, speed is meters per second, and acceleration is meters per second squared. In US customary units, or some people call them imperial units, you have square feet, cubic feet, feet per second, and feet per second squared. There's also miles per hour. So you can read the footnote here. The dimensions of a quantity will be symbolized by capitalized non-italic letters such as length, L or T. The algebraic symbol for the quantity itself will be an italicized letter such as L for length of an object or T for time. Nina, go away. All right, so the speed, velocity is length over time. Area is length squared. Okay, yeah, we're gonna skip this. I will do examples of dimensional analysis because what I would use. Ow! I just got a love bite. Here they're showing you an example where x, which is a distance, is acceleration divided by, or acceleration times time squared. If we ignore the 1/2, we'll see acceleration is length over time squared times time squared, and those cancel, so you'll end up with a length. And I won't go through the rest of it. I don't see it as that useful. But dimensional analysis is very important. If you consider, if you're working with equations and you end up with you're looking for a speed, meters per second, and if you end up with kilograms when you cancel all the dimensions, you've done something wrong. So dimensional analysis is important, and it doesn't tell you that your answer is right, but it can certainly tell you that you're going in the right direction. So you can ignore the bottom half. If you want to read it, certainly it's useful. I don't particularly like that method, so I'm just going to skip it. Okay, dimensional analysis can give you the numerical value of constants of proportionality that may appear in an algebraic expression. Is that true or false? No, it won't give you it's false, because it won't give you a numerical value. All it has to do with is the dimensions, whether it's length or time or mass. Okay, and we'll stop it there. And next we'll pick up conversion of units. So let's stop the recording.